Thank you again for inviting me. I'm going to show you a little bit of the work that we've been doing recently, part of my PhD program and also my postdoc. And it's about how to involve a little bit more ecological ideas into the surveillance of biodiversity, and in this particular case, zoonotic pathogens. Um, Let me start with talking about, I'm not gonna say anything about the need of surveillance of pathogens because I know all of you know even more than me about that. So let me start with like the idea of where to go for pathogen surveillance. And this has been around the question of many scientists recently because of all the things that have happened. But also, it's not a new idea. People have been concerned about this topic for several years and decades now. So people have been gathering data and showing maps like this that tell us where outbreaks have happened before, emerging and re-emerging infectious diseases where they have happened. If you see it from one point of view, you obtain this kind of map. Then if you see it from another point of view, from like showing where reservoirs of potential diseases are, you can see it from a different perspective, and you can obtain maps like this. And even you can go further and try to make predictions about what's probably going to happen, considering multiple conditions, not only where um, reservoirs are right now, but new potential reservoirs of diseases exist. And so if you notice, if you change the information you analyze, you can get different results, slightly different results, but that results that may matter. And so I think the clear message from all this previous analysis is that we need information, and the more information we have, the better. That way we can present more complete maps, more complete predictions and things like that. And so for this need to gather data, uh, the idea is that we need to go and actually check what's there. And in a previous work that we developed in my group, we started studying the idea of making the consideration of environments more clear and more direct into ideas of where to go for surveillance for biodiversity in general. And so the idea was to compare multiple ways to select sites for sampling. If you do it randomly over a geographic region, if you do it spread over the geography, if you do it spread over the environment, or if you consider both environments and geography, and what's the implication of that. And so we picked this particular geographic region, which is Mexico, because of the existence of more or less well-mapped biodiversity data. And so once you get all these different scenarios of picking points to go and sample, then you can go and check what happens when you sample that biodiversity in those areas. And so I know this is a lot of plots, but I want you to please focus on this region here. And the idea is that no matter what other method of sample or selecting points you obtain, when you consider first environment and then geography in concert, um, you always get better results than with other methods and than with if you do it just randomly. One particular aspect that was important to highlight here is that if you do it randomly in geography or you spread in geography your points, you tend to underestimate certain environments that are not so common in the geographic region. And those environments may be perfect opportunities for rare biota to exist that we are not really considering if we're sampling that way. And so using those same principles, we wanted to improve long-term pathogen surveillance in Panama, specifically zoonotic pathogens. And so here, Panama, you know where it is. It's in connecting South America and North America. It's a very interesting biogeographic site because it shares biota from both continents, and it's the bridge that connected these two big land masses. And it's interesting from many points of view from biodiversity. But during the years 1999, 2000, and so on, there was a big outbreak of hantavirus over there, with multiple um, fatal cases, and so there was a need to sample what's going on and where it's coming from, and who, people from there, institutions from there, were concerned about that, especially the Gorgas Institute of Health. And so, together with the Museum of Southwestern Biology, they started a massive effort in which they went with big crowds of people and sampled a lot of places in Panama. And so, this involved going there and sampling mammals, and especially mammals. They have sampled other groups as well, but especially mammals, and then do a holistic collection of tissues and information, and then doing lab work and to test and see where hantavirus was coming from and what were the dynamics and all that. And so from there, if we want to improve that, we were looking at summaries of the information that they have collected. So if you, this is a lot of points and a lot of things, but if you see block by block, this is showing us the number of sampling days per locality, which indicates kind of like the effort that has been put, the number of species documented, which is low in a sense here, but like here in particular, I'm working only with rodents, and the number of species, specimens per locality, which, as you can see in some of those, is very large because of the amount of times that people have gone there and the interest in those regions. Because, as you can see in the last part, the hantavirus seroprevalence per locality is high in those regions, and it well, in that particular region, in the central south part of Panama, in the peninsula, you can see that there's a lot of hantavirus cases, but also a lot of specimens collected. And so it was a high interest to go there and see what happens. But how do we know if what we're doing it's good and what we're doing is complete? We don't really have a lot of information about the whole panorama of biodiversity in Panama, and not almost nothing about like pathogen diversity in Panama. And so what we wanted to do is like apply the same principles and start analyzing Panama from an environmental point of view. And so we summarize environmental conditions across Panama into principal components, we can manage the information a little bit better. And so basically what you're seeing here in this cloud of points with a density representation, it's all environments present in Panama represented by two first principal components of an analysis done with multiple variables representing temperature, precipitation, and other things. And so here you're seeing where the points in geography are located in environment. You're also seeing how dense some of the environments are, which is to say how common they are in geography. And so everything that is more yellowish in the bottom plot, it's a lot more common than everything that is darker in color, which is to say they are present in more areas in Panama. And so, as you can see, many of the points that have been sampled are in those common environments. And a lot of the environments that are less common are not actually sampled. And if we see accessibility in Panama, which is represented in the map with a grayish color, it's a buffer of 2 kilometers around uh, roads in Panama. Then that can also be represented over this environmental plot, and these darker regions, black regions, are actually non-accessible due to the distance from roads. But the good thing is that most environments are actually accessible by road. And just a few regions that are accessible are actually not sampled. So there were good news and bad news from this whole effort of sampling in Panama. The good news is that they have sampled quite a bit of the environmental space in Panama, and the bad news is that there were some key sectors that were not sampled. And also there were some key sectors that are not really accessible. And so if we compare those environments that were sampled versus everything in Panama, then we see these light points here that show this is not actually sampled. And then if we compare everything that is accessible in Panama versus everything that exists in Panama, then there are only a few regions that are really we will miss if we sample what is accessible. And this is more a geographic representation of it. And so using this information, a lot of people working together and ideas coming back and forth and discussions about where to go, we picked a few sites that were representing core sites that we would like to sample in Panama just to be able to keep going there every season and every year and represent an actual dynamic of diseases and potential and zoonotic pathogens that are occurring over there. So these red points over here in this meshed area in the environmental space in Panama are representing those core sites. Then we selected other additional sites, which were actually sampled before. So from all these counter points, you have these other points over here. And so the idea was to addition other strategic sites, but also at least take care of this region over here that wasn't really sampled before. And so this region over here, if you translate it and put it together again and back into geography, it's actually in this little region of Panama over here. And so if you go further and put all these potential sampling points in the geography, you get this. You can keep going, just keep zooming in into this, you start seeing what's the actual geographic scenario of this. And so you pick one of these points that allows you to have accessibility, allows you to represent some kind of mosaic of landscape. And it's also relevant because it has human settlements around. And so that's more or less the dynamic that we went through, or the pipeline that we went through to select this final point. And with that, we selected these points here that, as you can see, kind of cover pretty well environmental conditions in Panama. And this was the only point that wasn't really sampled before, this 10th point. And as you can see, there are some points like the idea of including geography and environment together in these decisions. It's interesting because, as you can see, point number 1 and 2 are kind of among the most distant ones uh, in environmental space. But in reality, in geography, they are pretty close. And the fact that they're close allows for uh, faster accessibility and easier accessibility, actually. Um, and so it only shows how different our minds can work if only considering geography comparing when we also consider environment in these decisions. And so once we got all of this, of course, we wanted to attach our original ideas in discussions about why we picked those points. Why we picked a point close to the Panama Canal? Well, it's a really accessible point, first of all, for institutions that are concerned about sampling, but also it's in one of the points in which things across the entire world pass. And if something was to come from all this transportation and these movements that happen over here, this is a really crucial point to start looking at. This point over here is of high relevance because of all the Darien socioeconomical dynamics that happen over here in migration of people. And these points over here, this is a very interesting point because it has very unique and diverse biota. These points over here are crucial still for the country because hantavirus hasn't stopped being a problem over here. And so once you see this panorama, you can have Panama sample in a very strategic way with 10 sites that are a lot easier to sample than the hundreds of points that have been sampled before. But now in a more coordinated and elaborated way. And the only thing that remains for us to do is to go and check each of the points. Of course, we have done this before for many of them. But the idea is that if this was to be applied in a different geographic region, then the analysis don't stop there, but actually they need to be considered a more localized and a more locality-based way, and fine-tune these site selections, but also fine-tune all the techniques that were to be used for sampling and for detecting zoonotic pathogens over there. And uh, well, with that, I would just like to acknowledge all the contribution from a lot of people and the co-authors of these papers and a lot of the institutions that have been involved, considering also our sources of funding. Thank you.